What happens to a function as you get closer and closer and closer to a number? That is the idea behind limits. And once you understand this, the rest of calculus becomes simple. What is a limit? A limit describes what value a function gets closer and closer to as x approaches a number. For instance, if you have the function f of x, you want to find what is the behavior of the function as x approaches 2. When we talk about limits, we care about approaching and not necessarily reaching the value. Here are 3 quick methods to evaluate limits. First, you can use direct substitution. If the function is continuous at the point, you can simply plug in the value, and that is the fastest method when it works. If not, you could use algebraic simplification. You can factor, cancel, or rewrite to remove undefined behavior. This is essential if you're handling tricky expressions. And finally, we have special limits. They are useful for functions like piecewise and rational expressions that require specific techniques. Let's look at this first example. We will evaluate this limit. Limit as x approaches 3 of the function 2x plus 5. First, we can identify here that the function is continuous at x equals 3. 2x plus 5 is the equation of a line, so we know that is continuous. So we can simply plug in the value directly. Replace x by 3 into our equation, so that will be 2 times 3 plus 5, which will be 6 plus 5 equals 11. Therefore, the limit as x approaches 3 of the function 2x plus 5 is 11. Now, what if it's not possible to simply plug in the value into the function? We want to calculate the limit as x approaches 4 of the function x squared minus 16 over x minus 4. Where clearly if I plug in 4 in the denominator, 4 minus 4 will be 0, and I know that my function will be undefined. So in this case, let's see if we can factor. If we look at our numerator, x squared minus 16, that is a difference of squares. So this could be factored as x minus 4 times x plus 4. And if we rewrite our equation, our numerator is x minus 4 times x plus 4. Our denominator is x minus 4. X minus 4 and x minus 4 will cancel each other out, and we'll be left with simply x plus 4. So if we want to find the limit as x approaches 4 of x plus 4, we can simply plug in the value x equals 4, and that'll be 4 plus 4, which is 8. So even though the function is undefined at x equals 4, the limit as x approaches 4 is 8. Please show your support if this helps you understand limits better, and subscribe to get more fast-track math lessons delivered straight to you. Let's look at another example. When evaluating a one-sided limit, we approach from only one direction. In this case, we want to find the limit as x approaches 1 from the left of the function 3 minus x. So what we could do, we could find values as they get closer and closer to 1 from the left. That means values that are less than 1, but they're really close to 1. So for instance, if we plug in x equals 0.9 in this equation, and we can simply substitute because that is the equation of a line, we know that it is continuous. So when x equals 0.9, 3 minus 0.9 is 2.1. If we plug in x equals 0.99, 3 minus 0.99 is 2.01. So we could keep this going and do x equals 0.999 and x equals 0.9999, but we will see that as x approaches 1 from the left, the function will approach 2. And if we look at the graph, this is a straight line. As x approaches 1 from the left, we can see that the function gets closer and closer to 2 right here. So here is the faster formula shortcut. If f of x is a polynomial or a rational function where the denominator is not equal to 0, you can always use direct substitution. This saves time and simplifies your work dramatically. Now, here's your challenge. Try solving this limit on your own before checking the solution. So, we want to find the limit as x approaches 5 of the function x squared minus 25 over x minus 5. So clearly, if we simply substitute x equals 5, we will see that the denominator is 0. So we'll need to do some algebraic simplification before we can find the limit. So drop your answer in the comment and we'll pin the first correct one. Limits are about approaching. Focus on what the value gets closer to, not necessarily what it equals at that point. In this video, we covered direct substitution and algebraic simplification. In the next, we will see special limits. And the more limits you evaluate, the faster you recognize which method to use. You now understand the basics of limits, and this is one of the most important ideas in calculus, since limits are the foundation for derivatives, integrals, and continuity. Thanks for watching. Like, subscribe, and don't forget, math success starts when you stay on the fast track.